Dear students, welcome to the video partial fractions. Now, partial fractions, case 1, proper fraction where the denominator has distinct linear factors. Now, look at this case, px plus q over ax plus b times cx plus d. As you see, the denominator is a quadratic function. در واقع it will be leading coefficient will be a cx squared, while the numerator is linear, so it's a proper fraction. Now this proper fraction can be split into, and you see here there are two linear factors. The title is has distinct linear factors. There are two distinct linear factors, ax plus b and cx plus d. It can be split into these fractions a over ax plus b plus b over cx plus d. A and b, I mean capital A and capital B, are the unknowns to be found using these, because p, q, a, b, c, d are known. Actually, they are coefficients of the given question. Now, if you have 3, you can actually use the same method, px plus q over ax plus b times cx plus d, ex plus f. It's the same. It will be a over the first factor plus capital B cx plus d and plus c over ex plus f, where a, b, and c are actually unknown coefficients to be found. Now let's see some examples. Now the first example for the first case, 2x minus 13 over 2x plus 1 x minus 3. Now you see that here you have first a proper fraction, because denominator is quadratic and it is linear as an numerator, and you have two distinct linear factors here, so it can be written as a over 2x plus 1 plus b over x minus 3. Now there are two actually different methods to find a and b. I will solve this question using both methods. Method 1 is actually equating these two expressions. I first take a common denominator on the right hand side. I multiply by x minus 3, and this is multiplied by 2x plus 1, so it will become 2x plus 1 times x minus 3. Now I expand, it will be ax minus 3a plus 2bx plus b. Now I write the left hand side, 2x minus 13 over 2x plus 1 x minus 3. Now these two are like terms. I factor x, write a plus 2b, and these are the constant term. I write b minus 3a over 2x plus 1 times x minus 3. Now they have the same denominator, so numerators must be the same. Actually, when you equate them, corresponding terms must have the same coefficient in both expressions. Now, coefficient of x on the left hand side is 2, on the right hand side is a plus 2b, so is equal to 2. The constant term is b minus 3a. Let me write minus 3a plus b is equal to minus 13. Now you have a pair of simultaneous equations. I can make, for example, a the subject here. A will be 2 minus 2b, replacing in the second one, so it will become minus 3 times 2 minus 2b plus b is equal to minus 13, so it will be minus 6 plus 6b plus 6b plus b is equal to minus 13. So 7b is equal to, then it will become negative 7. B will be negative 1. So b is negative 1, and then a will be, we can replace here, a will be 2, it will be 4 then. So this fraction can be written as a is 4, so 4 over 2x plus 1, then b is negative 1, so negative 1 over x minus 3. It is split into partial fractions. This is actually the answer. So it was alternative 1. It is the first method. Now we will solve the same actually question using now another method, which is actually choosing values. Now alternative 2, choosing appropriate values. So again I write this proper fraction to x plus 1 over x minus 3 is to be written as a over 2x plus 1 plus b over x minus 3. And as you get common denominator, denominators then would be the same on the left and the right hand side. So then it will become 2x minus 13 is equal to, this fraction is to be multiplied by x minus 3, so it will be a times x minus 3 plus, this fraction is to be multiplied by 2x plus 1, so b times 2x plus 1. Now by choosing appropriate values, I'm going to find the value of a as well as b. Guys, look at here. If I put, for example, if I want to, because we have two unknowns and one equation actually. If I select x as 3, then this a will be actually eliminated. So if x is 3 on the left hand side, you have 2 times 3 6, 6 minus 13 negative 7, then it will be omitted. So you will have 2 times 3 plus 1, which is 7b. Then b will be negative 1, so b is known. Now you can now use actually negative 1 over 2 as x, then b will be cancelled out. X is negative half, so it will be 2 times negative half, it will be negative 1, negative 1 minus 13, negative 14 is equal to a times negative half minus 3, then negative half will make it 0, so b will be omitted, so it will be negative 14 is equal to negative 3, it would be minus half, it would be negative 7 over 2a, then a will be, you can cancel negatives, 2 times 14, which is 28, divided by 7, a will be for the same answer as we got in the previous method. So then it will be written as a is 4 over 2x plus 1 and b is negative 1 over x minus 3. Now case 2, proper fraction with a repeated linear factor in actually denominator. Now look at this case, px plus q over ax plus b squared. Now as you see here, you have a proper fraction in which you have a repeated linear factor. Repeated means that you have more than one factor is repeated more than actually once. It has power 2. It is ax plus b times ax plus b. Now it can be split into partial fractions using the rule a over. First you write first power, then second power of the same factor, where a and b are the coefficients to be found. Now let's look at one example. Example 7.2, express 2x minus 11 over x minus 4 squared in partial fractions. Now 2x minus 11 over x minus 4 squared. So it will be a over x minus 4 plus b over x minus 4 squared. Now, if I take a common denominator on the right hand side is to be multiplied by x minus 4. So it will be a x minus 4 plus b over x minus 4 squared. Now consider this and these fractions in order to find a and b. So 2x minus 11 should be equivalent to ax minus 4 plus b. Now I solve choosing appropriate values for x. If x is 4, so 2 times 4, 8, it will be minus 3. A will be eliminated, so it's equal to b. B is negative 3. Now b is negative 3, so you can choose another optional value for x. For example, you can choose now 0. So 2 times 0 minus 11, negative 11 is equal to a times 0 minus 4 plus b, which is negative 3. So minus 11 is equal to minus 4a minus 3. So minus 4a will be negative 8. Then a will be actually then 2. So then you can write split into partial fractions. So then the fraction, sorry, I should write here. So it will become a, which is 2 over x minus 4 plus, where is b, negative 3 over x minus 4 whole square. This is the answer. Now, next example, we have 1 minus 9x minus 8x squared over x minus 2, 2x plus 3 squared. Now, as you see in this example, we have combination of the two previous cases that we saw. We have x minus 2 and 2x plus 3, which are two distinct factors, and 2x plus 3 is actually a repeated factor. So when you want to split into partial fractions, it will be written as a over x minus 2 as a distinct factor plus now b over, you should follow here the second case, so 2x plus 3, then c over 2x plus 3 squared. Now if you take a common denominator on the right hand side, minus 8x squared, I write x minus 2, 2x plus 3 squared. It will be, now the common denominator will be 2x plus 3 squared and x minus 2. So the first fraction should be multiplied by 2x plus 3 squared. So it is x minus 2 times 2x plus 3 squared. The second fraction needs to be multiplied by x minus 2 and 2x plus 3. And the third fraction just needs to be multiplied by x minus 2. Now denominators in both sides are the same, so there's no need to consider them. Now we have 1 minus 9x minus x squared is equal to a times 2x plus 3 squared plus b times x minus 2 2x plus 3 and plus c times x minus 2. And now we can actually first to eliminate these two, if you replace x by 2, it will be on the left hand side, it will be 1 minus 18 minus 32 is equal to, then it will be 0, it will be 0, so it will be 2 times 2, 4, it will be 49a actually. So on the left hand side we have also minus 49 is equal to 49a, then a will be negative 1. Now a is negative 1. Now in order to find for example c, you can replace x by negative the root of these brackets, these two are actually negative 3 over 2. Then if you replace it on the left hand side, we will have negative 7 over 2, then is equal to, this will be cancelled out, will be 0, this one as well, so then it will be minus 3 over 2 minus 2, which is negative 7 over 2 c, then c will be 1. Now you have both a and c. Now in order to find b, so you have just one unknown left, you can replace x by 0. If you put 0 here on the left hand side, you have 1, then it will be 9a, which is actually a is negative 1 minus 9, then plus, it is negative 2, it is 3, negative 6b actually, minus 6b, then minus 2c, c is 1, so it will be then minus 2, then minus 2 minus 9 minus 11, so it will be 12 is equal to minus 6b, b is negative 2. Now it has been split into, so I write it here, a is negative 1, so negative 1 over, there is not enough space here, I write here negative 1 over x minus 2, then b is where is b on negative 2 over 2x plus 3, and c is 1, so plus 1 over 2x plus 3 squared. Now as you see, it has been split into partial fractions. Now the third case of partial fractions is a proper fraction with a quadratic factor in the denominator that cannot be factorized. So then it will be split into partial fractions using this rule, actually px plus q over now ax plus b times cx squared plus d. Now here is a quadratic which is not which cannot be factorized, so it will be a over, the first factor is ax plus b plus, now it cannot be factored, so you write the same factor in the denominator, but as it is quadratic, a linear one is placed as numerator, and a, b and c are the unknown coefficients to be found. Now let's solve one example for this case, case 3. So 8 plus 2x minus x squared over x minus 1 x squared plus 2 now can be written as a over x minus 1 plus, now it's a quadratic factor which cannot be factorized, so we write bx plus c over x squared plus 2. Now if I take common denominators, it will be a times x squared plus 2 plus now bx plus c times x minus 1 over x minus 1 times x squared plus 2, then 8 plus 2x minus x squared is to be equivalent to a times x squared plus 2 times plus bx plus c times x minus 1 minus 1. Now, to omit b and c, you can simply replace x by 1 is the root of this expression. So it will be 8 plus 2 minus 1, which is 9, is equal to, then it will be 1 squared plus 2, which is 3a. So a is 3. Now, in order to find b and c, you can, for example, let's replace 0 here, because if you replace x by 0, then b will be eliminated. So on the left hand side we will have 8, then it will be 2a, a is 3, so it will be 6, plus then b will be eliminated, it will be minus c, then minus c, then c will be negative 2. Now we have a and c. In order to find actually now b, we have chosen 1 0, so let's replace an optional value like x negative 1. If x is negative 1, 8 minus 2, it will be 6, 6 actually minus 1, it will be 5, then is equal to, then on the right hand side, if it is negative 1, it will be 3a, a is 3, it will be 9, then negative 2, it will become negative 2 times b times actually x is negative 1, it will be positive 2b, then and c is minus 2, it will be 4, then 2b is equal to 9 plus 4 13, it will be minus 8, then b will be negative 4. Now this fraction is split into a which is 3 over then x minus 1, then plus b is negative 4 and c is negative 2. I can factor negative here to write 4x plus c, which is 2, over x squared plus 2. Now it has been split into partial fractions. Now the last case, which is case 4, improper fractions. When sometimes you have improper fractions and you need to first, using the method that you saw in the first part of this chapter, by the long division, you can rewrite it as a sum of one polynomial plus a proper fraction. Then that proper fraction can be actually split into partial fractions, so then the answer will be a combination of a polynomial and some partial fractions. Now let's see one example. Now this example expressed 2x squared plus 5x minus 11 over x squared plus 2x minus 3 in partial fractions. As you see, you have improper fraction because the degree is the same in both numerator and denominator. So I first divide them, 2x squared plus 5x minus 11 divided by x squared plus 2x minus 3. So we need a 2 first, so it will be 2x squared plus 4x minus 6. If you subtract them, they cancel out. For 5x minus 4x, which will be x, minus 11, plus it will be then plus 17 minus 11, sorry, it would be minus 11 plus 6, which is minus 5. Now I rewrite this fraction, 2x squared plus 5x minus 11 over x squared plus 2x minus 3 can be written as quotient times divisor, which is 2 times x squared plus 2x minus 3, plus remainder, which is x minus 5, over x squared plus 2x minus 3. If you separate them, it will be, they cancel out each other, it will be 2 plus x minus 5 over x squared plus 2x minus 3. Now here you have a polynomial which is actually fixed number 2, so if you split it into, it will be 2 plus, now you can write x minus 5 over, if you factorize the denominator, it will be x plus 3 times x minus 1. So 2x squared plus 5x minus 11 over x squared plus 2x minus 3 now is equivalent to 2 plus, actually x minus 5 over x plus 3 times x minus 1. Now this part can be, this fraction can be split into, it is the first case, two distinct linear factors, x plus 3 plus b over x minus 1. Now I write it separately here. What we need to actually do here, x minus 5, we are just going to split into partial fractions this part. X plus 3 times x minus 1 is a over x plus 3 plus b over x minus 1. Now if you take common denominator, it will be x minus 1, here x plus 3, so x minus 5 is equivalent to a x minus 1 plus b times x plus 3. Now if x is 1, it will be negative 4 is equal to 4b, b will be negative 1. Then now I replace x by negative 3, it will be negative 8 is equal to, it will be 0 and negative 4a, so a will be then 2. Now replace it, don't forget to add this constant here, 2 plus a, which is 2 over x plus 3, b is negative 1 over x minus 1, and it is the final answer to this question. Now application of partial fractions. Sometimes these partial fractions can be used in order to evaluate the sum of some terms in a sequence. Look at this example. It is given that the algebraic fraction 1 over x times x plus 1 can be written in a partial fraction as 1 over x minus 1 over x plus 1. The question has already split into, but you yourself can also solve it and write it, a over x plus b over x plus 1. A will be 1 and b will be negative 1, so it will be split into these partial fractions. Now it wants you to actually evaluate the sum to infinity of these s to infinity of these sequence, which is, for example, 1 times 1 over 2 plus 1 times 2 over 3 plus 1 times 3 times 4 plus 1 4 times 5, and then, for example, 1 times n minus 1 times n and plus 1 times n times n plus 1, where n tends to infinity here because the sum to infinity is s. Now let's use the formula partial fractions here. 1, x here is 1, so it can be written as, it can be split into these two partial fractions, so it can be written as 1 over 1 minus 1 over x plus 1, which is 2. Then the second one can be written as 1 over 2 minus 1 over 3. Then the third one can be written 1 over 3 minus 1 over 4. Then this one can be written as 1 over n minus 1 minus 1 over n. Then the last term 1 over now n minus 1 over n plus 1. Now as you see here, these cancel out, these terms cancel out, these with next one, this with previous one, these two cancel out. So what do we have? Actually what we have left is 1 minus 1 over n plus 1. where n tends to infinity. So we know that when n tends to infinity, so 1 over infinity will be 0. It tends to 0, so then it will become 0, so the final answer will be 1. This sequence actually tends to 1 when n tends to infinity.